In our previous video, we were actually trying to find out what happens here, and then we concluded by finding that the amount of potential difference across the two terminals of a 5 microfarad capacitor is 8 volts. Now, the question is, if the capacitor is replaced with an inductor, look at the diagram here. Second diagram here has an inductor replacing a capacitor. So what will be what? Will be what? The
voltage.
The voltage and what?
The impedance.
And the impedance, right? So since the capacitor has been replaced, we need to find the impedance. We need to find the impedance, okay? And the impedance is going to be given as R squared plus XL, right?
Yes, sir.
Yeah, it's going to be given that way because SL squared, yes. But we need to find what XL squared is all about. We need to find the inductive what? Reactance, since we have a value. So L is the value of the inductor, right?
Yes,
giving us 150 millihenry. So we need to convert 150 all over what? 1,000. Okay? We cancel out wisely, right?
Yes, sir.
Are you with me?
Yes, sir.
So what will it give? 0.15 Henry, right?
Yes, sir.
Now we now have our new value is 0.15 Henry, right?
Yes, sir.
Good. So with this, we have started. So with this, we can now calculate the what? The impedance. We have found the inductive what? The reactance. We have found inductive reactance. So if we now substitute wisely here, we'll be able to find the what? The impedance. So let's quickly do that without wasting time. What we need to do now is to find the impedance quickly. Begin to substitute. Impedance can be found using square root R squared plus XL squared, and this becomes for R we have 500 squared, right?
Yes, sir.
And then for inductive reactance, right?
Yes, sir.
We have what?
0.15 squared.
No, that's the value of the inductor, right? So we need to do this. Inductive reactance is 2 pi, okay? Times frequency 50, right?
Yes, sir.
Are you with me?
Yes, sir.
Times the inductor itself, which is 0.15 Henry, all squared. So what do you do now? You have got some work to do. You have to punch some buttons now. 2 times the value of pi. Are you there?
Yes, sir.
Then times 50.
Yes, sir.
And then finally times 0.15, which is the value of the inductor measured in Henry. So what do we have? Just take your time, take your time, take your time. Already we have that this is 250,000. All right, so evaluate these. Come closer, can you? Can you? All right, so call the value, just this. So what did you get? No. First of all, evaluate this 2 times pi.
Yes, sir.
Go back again, and I want to hear a voice.
Yes, sir.
2 times the value of pi. Did you do that?
Yes, sir.
Times 50. Did you do that?
Yes, sir.
Times 0.15. Did you do that?
Yes, sir.
So give me exactly what you have here.
Raised to power 2, right?
No, before that.
Before that.
Okay, raised to power 2.
Okay. 2, 2.
Give me 2, 2.
2, 1.
Another 2.
Yes.
And then 1.
0.23.
Point what?
2369.
2, 3, 6 what?
9.
9. All these values, right?
Yes, sir.
For this, did you square?
Yes, sir.
Did you do the square?
Yes, sir.
Good. Now, what do we do next? Quickly add.
Okay.
Quickly add 250,000 plus 222, 1.2369. Let's see what we have.
Okay, sir.
What do we have? What do we have? Okay, are you still working on this? So
Yes.
the total of this will give you something we are going to put down as our answer quickly without wasting time.
2, 5.
So our impedance now, is that what you're trying to tell me?
Yes, sir.
Did you square it?
No, I did not
You've
square
not
it.
squared, so let's continue with this. 2 what?
2, 5, 2.
2, 5, 2,
2, 2.
2 again.
Yes.
2, 2,
1 point.
1 point what?
2, 3, 6, 9.
2, 3, 6, 9.
Yes, sir.
Can we find the square root this time around? So that's
Yes, sir.
okay. Are you still there?
Yes, sir.
Just try and get the square root. What's the square root of 2, 5, 2, 2, 2, 1 dots, 2, 3, 6, 9? If you have watched up to this point, you have found value in this, why don't you consider subscribing, giving us a thumbs up, and then share with your friends, networks. Forget not to put on the bell button for constant notification. Come on, let's have the final answer here. What do we have?
502.2.
5, 0,
Yes.
2 point what?
216.
216. Remember, impedance is measured in what?
Ohm.
Ohms. So, right?
Yes, sir.
Approximately we have this as 502 point what? 3 ohms, right?
Yes, sir.
Good. So we have finally succeeded in finding the value of the impedance, right?
Yes, sir.
So what is the next question? Quickly.
Voltage.
Voltage. Voltage across the capacitor. Is it across the capacitor or across the inductor?
Oh, the inductor.
The inductor, right? Because in our previous class we found voltage across the potential difference across the capacitor, right?
Yes, sir.
So this time we are going to find the potential difference across the inductor, right?
Yes.
Which means the inductive what? Voltage, right? The inductive voltage. So the inductive voltage is going to be found using VL is equals to current flowing in the circuit, right? Times X what? L. So what's the value of XL? Very, very important, because we need to know the value of XL for us to move on. What you need to do is to go back to this. Okay, we already have it here, right? But we squared it. We squared it, so we have to evaluate this without squaring it. Quickly. Current is known, all right? Current is known to be 0.012 times. We are going to multiply by the value of the inductive reactance. Let's find the inductive reactance. Once we do that, we are done. So what do we have? 2 times the value of pi times 50, all right?
Yes, sir.
Times 0.15.
47.13.
Huh?
47.13.
47 point what?
13.
47.13, right?
Yes, sir.
Are you certain about this?
Yes.
Are you sure?
Yes, sir.
Good. So finally what you do for me is multiply 0.012, the value of the current found, times 47.13. Are we there?
Yes, sir.
So what do we have? 0.012 times 47.13. What do we have?
0.563.
Okay. 0.5,
6556.
not 5.
0.56556.
Okay. 0.655, right?
Yes, sir.
Right. So this is measured in volts, right?
Yes, sir.
Good. So this is the value of the inductor. The value of the voltage or potential difference across the terminals of the inductor. So what we have here, what this means is that we have approximately 0.66, right? 56, I mean, volts. Okay?
Yes, sir.
Across this potential difference across the inductor, right? Solved. Solved. Do you have any question?
No, sir.
I think it's clear, right?
Yes.
Good. Go ahead and then make some attempts. See you in my next class. Don't forget, right?